So inverse functions. Inverse means the opposite, right? Inverse means the opposite. So when we talk about inverse functions, it means if I take one function and completely flip it around. So what do I mean? Well, the previous x's are now the y's, and the y's are the x's. So if I was to take something and completely swap it, so y's become x's, x's become y's, it becomes a new function. That's an inverse. They're inverses of each other. Okay? So that means the domains are the x's, the ranges are the y's, they're swapped. Everything's swapped like that. So if you were to graph them, we're not going to graph them, but if you were to graph them, they would be symmetric over the line y equals x. The line y equals x is the diagonal line, so they'd be symmetric across that. We're not going to graph them, but this is just some background on inverses. Okay. For f to have an inverse, some things have inverses, some things don't have inverses. Okay. So for it to have an inverse, it must pass the one-to-one test. So a one-to-one test, or one-to-one, means it passes the horizontal. So you know, like in Math 1, in junior high in Math 1, you do the vertical line test to see if it's a function. Well, the one-to-one means it passes the horizontal line test as well. Same thing, but just horizontal line. Okay, so it has to have one of that. So like, for example, let me give you an example. Quadratic. A quadratic passes the horizontal or the vertical line test because it doesn't hit, the black is only hitting my ruler at one spot at every time, right? But if I flip it around, will it ever hit in more than one spot? Yeah, everywhere, right? So quadratics don't have inverses. Okay, quadratics don't have inverses. Let me draw another one. That is to the fourth power. A quartic, same thing, right? It's going to pass the horizontal line test, but it won't, or the vertical line test, but it won't pass the horizontal. That's to the fourth power. So anything to the second power, to the fourth power, to the sixth power, to the eighth power, anything even won't have an inverse. So everything we look at today, the powers will either be 1, 3, 5, 7, right? We won't have any quadratics or anything like that because they don't have inverses. Okay? That's what that says. Let's see. So yeah, it has to be monotonic. Monotonic means always increasing or always decreasing. Quadratics do both. Quadratics increase and then decrease, or decrease and then increase, right? So those aren't considered monotonic. So those won't have inverses, okay? Here's the big thing right here. That little -1, f to the -1, looks like a -1 power. It's not, but it looks like that. That means inverse, okay? So if I say this is f of x, and I say this is f of -1, that means they're inverses of each other. Okay. So the first thing, how do you find an inverse? What is an inverse? How do you find an inverse? Well, I have a few examples here. So let's do this. It's pretty easy. The idea of finding inverses is pretty easy, but you might not have done it before. Okay, so if I have f of x, what is its inverse? Pretty easy. Flip x and y. That's the first thing. Swap them. Well, f of x is y, right? Sometimes we write function of x instead of y. So f of x is going to become x. X is going to become y. So we're going to rewrite it. That's the first thing. Okay. Then you solve for y. So I'm going to subtract 2 from both sides. Divide by 6. That's its inverse. Both of these guys are inverses of each other. That's how to find an inverse. We're not going to be finding inverses, but I wanted to give you some background on how to find an inverse. Okay? I'll prove it to you, watch. They're inverses. I'm going to make an x and a y table for f of x, and then I'll make an x and a y table for f to the negative 1 of x. Okay. So I'm going to plug in some numbers. 0, 1, 2. So if I plug in 0 to f of x, what do I get? 2. If I plug in 1 to f of x, what do I get? I plug in 2, 13. 14? Yes, 14. Sorry. Watch this. 14. What happens when I plug in 2 to the bottom one? What do I get?
0.
What happens when I plug in 8 to the bottom one? What do I get?
1.
What happens when I plug in 14 to the bottom one? What do I get?
2.
What do you notice about the x and the y tables? They're completely swapped. Yep, that works for anything. Any number you pick for x will always be swapped. That's just the relationship, their relationship. They're completely swapped. That's big for today. One of the things we're going to do is they're going to give us a table for f of x. We need to create a table for f for the inverse. Okay? Okay, so let's do one more. So first thing you do is swap x and y. So this guy is going to be x. This guy is going to be y. Solve for y. Subtract 3 from both sides. Take the square of both sides to get rid of the root. And then add 5 to both sides. So y equals x minus 3 squared plus 5. Both of these guys are inverses of each other. They're inverses of each other. I could do the same thing. I could make a table, and I'd get the same thing, the same values. Okay? That's how to find an inverse. It's pretty easy to find an inverse. You just switch x and y and solve like you've been doing forever. Okay? But what we're going to do today is find derivatives of these guys, of the inverse. Okay? So what they're going to do is they're only going to give you parts of it. They're going to say this is f of x. Find the derivative of its inverse. Okay? That's what they're asking you to do today. Okay, so how are we going to do that? Well, that's what these guys are for. That's what these guys are for. So I have lots of different options, but they're going to give you two types of things. They're going to give you equations and say, find the inverse, or find the derivative of the inverse. Or they're going to give you tables. So depending on what they give you, these are the weapons we're going to use. Okay, this is what we're going to use. So if they give you a table, we're going to use this guy in the blue. If they give me an equation, this is the guy we're going to use with those steps over there. Okay, these are the things we're going to use to solve, to answer the question. So it just depends on what they give us. Okay. Okay. So they're the same thing, but one is easier for tables, one is easier for equations, but they're the same thing. So it's not like they're different, they're just written differently. Okay. All right. Okay, so the first one. So the first one we look at is going to be on the next page. So example number 2. Is that a tables problem or is that an equations Equations. Yeah. Do you see a table anywhere for number 2? I don't. So that means we're going to be using the pink. We're going to be using the pink. We're going to be using the steps here. The steps over here, which will create this stuff over here. Okay? Okay, so it says find the derivative of the inverse functions. Okay, so we have f of x. F of x is x cubed. You notice how it's not an x squared, it's an x cubed because x squareds don't have inverses. So they got to go to the next one, x cubed. Plus 4x plus 2. Find the derivative of its inverse at -3. So we got to find the derivative of its inverse. We got to do 2 different things. So let's use our steps. So steps say, if you're trying to find that guy there, set f of x equal to a and solve for x. Okay. What is a in our case? For our problem, what is a? -3. So we're going to set f of x equal to -3. X cubed plus 4x plus 2 equals -3. Here's where it's a little, not difficult, but it's just a little weird. This guy's not a quadratic, so we can't solve it like a quadratic. So we're going to kind of have to do mental math in our head. What value of x could I plug in for x and would give me -3 as an answer? Like, for example, if I plugged in 0 for x, I get 0 cubed plus 0 plus 2 would be 2, right? So what number could I plug in for x that would give me -3 as an answer? -1. So if I were to plug in -1 here and here, -1 cubed is -1 minus 4 plus 2. That would equal -3. So x is equal to -1. That's our first step. That was our first step. Okay, so let's go back to our other steps. Step 2, find the derivative of f. Find the derivative of f. Okay. 3x squared plus 4. Done. Okay, so this was step 1. This is step 2. Next, find f prime of whatever answer you got from step 1. So what answer did we get from step 1? -1. So we're going to find f prime of -1. So I'm going to plug in -1 for x. And I get 3 plus 4, which is 7. Okay. Last step. Flip it. So I mean flip it, what do I mean? Instead of 7, it's 1 over 7. Yeah, 1/7. Yep. That's your answer. 1/7. F to the -1 prime of -3 equals 1/7. Most of these answers, if not all of them, are going to be fractions, are going to be fraction answers because of that last step. Because of that last step. Unless you have a fraction already, it's always going to be a fraction. Okay? All right, so I want you to try B. Try B now. Do B on your own. We'll do it together, but I want you to do. So you're going to do the 4 steps we just did because it's another equation. So I haven't finished yet, but at least I did two of the steps, haven't finished the third one. So step one, if I were to plug in positive 2, that would give me a 1 as an answer, because 2 to the third power is 8. 8 minus 7 is 1. Square root of 1 is 1. Then I found the derivative. Well, I had to use a chain rule to find the derivative. And then the step I haven't finished is plugging in that number into the derivative. So when I plug in 2, I simplified it. So I have 1 to the negative 1/2 times 6. So what is 1 to the negative 1/2? It means flip it, and then what does 1/2 power mean? Square root. So if I flip 1 and find the square root, what do I get? 1. Mm-hmm. So I get 6. And then the last step is the easiest one, flip it. So g prime of 1 equals 1/6. Okay? Now, I'm going to be honest with you guys. These problems that we do today, if you were to do a whole practice test, AP test, you maybe see one of these problems. Maybe. Some years they don't even have one of these problems in there. They're very rare to see, but they do pop up time to time. So I always include this lesson. Every year I'm like, should I include this lesson or should I not? And I don't want, when you're doing an AP test, you're trying to get as many points as you can. These aren't hard problems, but if you've never seen it, it's hard. So I always want to include it. But like I said, on your test, the one we take next week or when we finish this chapter, you'll probably have one multiple choice question like this. That's it. There won't be any FRQs. These are one of the things that are it's not very heavily tested, the inverse, but it is important. That's why I include it. Okay. All right. Okay, so let's go to the next page. Okay, so now they're giving us a table. Okay. So let's go back to our steps. So we're going to use the top guy. Okay. So let me write it on the board so we don't have to keep flipping. So it says, if you're trying to find, you're going to use this fraction. 1 f prime f negative 1. Okay. Okay, so let's look at the problem. So the table below gives selected values for a differentiable decreasing function and its derivative. Okay, so g of x is the inverse. Okay, so they want us to find g prime of 1. So it's inverse of 6. So g prime of 6. First thing I'm going to do is I'm going to draw another table. I'm going to draw another table with it, right by it. This table is going to be the inverse. So f of x over here, x over here. This is the inverse table. How do I do that? You just flip it. Like the first one was, the first value was negative 3, 6. So over here, the inverse table is going to be 6, negative 3. 5, negative 2. Negative 1, negative 1. Negative 2, 0. Negative 3, 2. 6, negative 5. Okay, that's the first thing I do before I even do anything with that equation over there. Okay. So we're going to find g of 6. What's up? Did I do something? Oh, the last one. Sorry, I didn't flip the last one, did I? There we go. Oops. Okay. So now we're going to use that guy over there. So I'm going to set it up. 1 on top. F prime. F negative 1. But instead of x, what am I going to plug in? 6, because that's what the question is asking, right? That's what the question is asking. So I'm going to plug in 6. In math, we always start on the inside, right? We always start at the inside of the parentheses. So that's right here. The blue guy. On its inverse, when I plug in 6, what do I get? What do I get for y? So go to the inverse table. The other one. Oh, yeah. I don't know, yeah. So when we plug in 6 to our inverse, what do we get as a y? Negative 3. So that's the answer that goes there, negative 3. Okay. F prime of negative 3 is what? Here's f prime. Here's negative 3. Negative 1. Which equals just negative 1. You're done. Okay. So the first thing you're going to do is set up a inverse table, because the first thing they're going to have you do is find the inverse. Okay. Whatever that value is, whatever that y value is, you're going to plug in here. And then you're going to go to the f prime and find that, and that's your answer. Okay. So it's similar as the last one, but we don't have an equation to find the derivative of. They give us the derivative. So that's why we do it a little differently. That's why we do it a little bit differently. Okay. All right. So I want you to do letter D now. Do letter D on your own. So this one's an equations one. So we're going to go back to our steps that we did earlier. Okay. All right. So let's see. What is it? What would I? Is it 1? Positive 1? X equals positive 1? Oh, they give you the answer here too. When I plug in 1, I get negative 6. That's what I was looking for. Okay, so derivative. Plug in 1 to the derivative. I get negative 6 minus 1, which is negative 7. Flip negative 7. You're done. Okay. Okay, so I want to give you, before we go on to inverse trig, because that's a whole nother thing, I want to give you another problem that's a table problem. Because for some reason I only give you one on here. And I want to give you another one. So let me give you a different table. So E. You don't have to write down the whole problem, just enough of the problem for you to do it. So I want you to do this problem now. Okay, so set up my inverse table. I filled in my rule, what it said to use. So first thing I'm going to do is the inverse, the blue stuff, the blue thing I highlighted. The inverse, so that's the inverse table. So when I plug in -1 to the inverse table, I get -5. So that means this is -5. And then the derivative at -5 is +2. 1/2. Okay. Alrighty. Okay. Okay, so the last thing we're talking about is, it looks like a lot, but it really isn't. So the first thing is I want you to take out these orange sheets that I gave you guys a while ago with the trig values. And it's got the trig stuff on it, but I want to go on the back. So it's orange. It says green on here, but I gave you guys orange this year. So on your orange sheets on the back is the top is the derivatives. So 1 through 24 are all the rules we've talked about. All the rules we talked about. Every single one of them. And then the only ones we haven't talked about are 19 through 24. 19 through 24 are inverse trig, which is the ones you have up here. Okay? Inverse trig. Those are the only ones we haven't talked about. So after today, we've literally, these are all the equations, all the types of things you're going to be asked to find derivatives of. Okay? So these are one of the things, again, they're not tested a lot. On your test, I'll probably have one multiple choice question for this, one multiple choice question for your inverse. That's it, because they're not tested a lot, but they are tested. Okay? And then on your test, when you take, I'm going to let you use a note card, 3x5 note card. One side, just one side of the note card. Okay? Things like this might be helpful to write down so you don't have to memorize it. Okay? Because, or some of the trig stuff would be helpful so you don't have to memorize it. It's not going to be a big part of the test, but it is going to be part of there. So, inverse trig. Trig's always got to be a little different. So sometimes they don't call it inverse. Sometimes they say the word arc cosine, arc cotangent, arc sine, arc tangent, arc secant, arc cosecant. It's the same thing as inverse. Okay? It's the exact same thing as inverse. It's just sometimes trig's just a little different than other maths. So that's what they give you. Okay? So if it says arc, it means inverse. If they have that little symbol here, the -1, that's inverse. Okay? So we're literally just going to follow along this thing, right? They're going to say, find the derivative of one of these guys. And then you're just going to do whatever it says. That's all you're going to do. Okay? That's all you're going to do. So for example, let's do 3a. So I got to find the derivative of arc cosine for x squared. Okay? So I go to my rules. It says arc cosine. So this is my u, right? My u is x squared. Right? U in my case is x squared. So on top, it's going to be negative times the derivative of u. Okay? So the derivative of u is just 2x, right? I'm going to change sign, so it's going to be negative 2x on top. On bottom, 1, the square root of 1 minus u squared. U was x squared, right? So that's going to be x squared. Okay, so when I simplify it, it makes negative 2x over 1 minus x to the 4th. Done. That's the derivative. It's not hard, but it's just without these guys, you're kind of stuck. So that's why I'm going to let you use, that's one of the reasons I'm going to let you use, especially for this chapter, I'm going to let you use a 3x5 card so you can write down all that stuff so you don't have to memorize it. Okay, so you don't have to memorize it. Oh, sorry. Wait, did I do that right? Yes, I did. Okay. All right, so next guy. Inverse sine of square root of 2x. So u is this part here. That's 2x to the 1/2 power, right? Because the whole thing. Okay. So the rule says we're going to make a fraction again. The derivative on top. So the derivative goes on top. So the derivative of u. Okay, so I'm going to go do the derivative of u. U prime. 1/2 2x to the negative 1/2 times 2. The 1/2 and the 2 cancel out because they both multiply to be 1. So I'm left with 1 over square root of 2x. So I'm going to put that on top. Okay. The bottom says square root 1 minus u squared. Okay. All right. Calculus is done. Now we just got to clean it up. So I have a fraction on top. If I square a square root, that's just going to take away that. Last thing is I don't want a fraction on top, so I'm going to move the top part down. So square root of 2x times 1 minus 2x. Done. So you literally just follow along with the steps that you have here. Okay. Let's see here. Oh, okay. All right, so let's do, I don't think we're going to do D because I want to do E and then we'll be done. Okay, so y prime. X times, oops. So here, I have the product rule. This times this, and then I have the square root. So let me rewrite this. Okay. So derivative first. So derivative, the quotient rule says, or the product rule says the first times the derivative of the second. Well, the derivative of inverse sine is the derivative of u over square root 1 minus u squared. Okay. Plus the derivative of the first, which is just 1, times the second. So this is the derivative of this guy here. Now I have to find just this, the derivative of that part there. That part I don't need. I don't have any inverse sines or anything. So it's just going to be plus 1/2 1 minus x squared to the negative 1/2 times the derivative, which is negative 2x. So the 1/2 and the negative 1, the negative 2 will cancel out. So I get x over square root 1 minus x squared plus this guy plus x over 1 minus x squared. Oops, sorry, there's a negative there. What do you notice about the first and the last? They're the same but opposites, right? So if they're the same but opposites, when we combine them, they're going to make 0. So our answer is just what's left. Okay. Okay, so the last one. We're not going to do D just because it's more of the same. You would use arcsecant instead of the ones we've been using. So there was E. E I wrote in. See, I don't have it. Can you guys tell me what E was? So it was a limit problem, right? The limit as x approaches 1/3. And then it was x minus 1/3 on the bottom, right? And then what was it? Inverse sine of x of 1/3. Thank you. Perfect. Okay, so this looks a lot different than what we've been doing, right? What we've just been doing today. But it isn't. Does this look familiar at all? If instead of x's, I put h's? We've done this before. It's the very first thing we did in this chapter, right? It's called the derivative. It's called the definition, right? Well, with the definition, this right here was always the original. So everything else is meaningless except that part right there. So the original equation was this. And then what they want me to do is find the derivative and then plug in 1/3. That's what they want me to do. They want me to take this original plug it into the derivative. That's what they want me to do. That's where it comes from. Okay, everything else is meaningless. I don't need anything else. Once I realize, oh, this is just a derivative. So what we're going to do is we're going to find the derivative of this guy, which we've been doing, right? And then plug in 1/3. Okay, so let's find the derivative first. So arc sine or inverse sine says the derivative of u goes on top. Well, what's the derivative of x? 1. Over 1 minus u squared. Okay. Now plug in 1/3. One minus 1/9 square root. 1 minus 1/9 is 8/9. So I have the square root of 8 over the square root of 9. Well, the square root of 9 is actually a number. 3. Keep, change, flip. 3 over the square root of 8. I know you're not supposed to have a square root on the bottom, but for this case, yeah, just to, if that answer is not there, then just multiply by square root of 8. So it would be 3 root 8 over 8. Okay. And we're done. Okay, so tomorrow I'm not going to be here. I'm not going to be on campus tomorrow. So what I'm going to do is I'm going to give you